All right, so workplace 20, this is second part of 6.2, I guess. And we're taking a look at example 4 on page 299. So it says calculate the value of an investment of $5,000 that earns interest at a rate of 2.95% per year, compounded semi-annually, so that's n equals what? 2. That's 2 times per year for 3 years. So there's going to be 3 times 2 compounding periods. There's going to be 6 compounding periods there. Use a table to show the value of the investment to the end of each compounding period. So this is what you're going to be asked to do today, is to fill out this chart. Very similar to what we did in 6.1, maybe with the bank fees and stuff, kind of like keeping track of things. This one is now this is what the chart's going to end up when it's done, and I'm going to walk through this with you just so that you understand what this means. So what we're going to do is we're going to find out what the value is at the end of each of the compounding periods, and what we're going to do is basically we're going to use simple interest formula to do that. Okay, so we're not going to use the compound interest formula, because the compound interest formula only gives us this one at the end. Okay? So this question says, take a close look at how your investment grows, like what is the value at the end of each period. Okay, so that's what we're going to look at here today. All right, so what we have to understand is that if this interest is split 2 times a year, we actually use half of the yearly interest rate. You guys know that, right? Because in our formula, and let's see if we can go back and see a formula here real quick. So see this formula right here? Right? If n is 2 times per year, like semi-annually, then the rate is divided by 2. You see that? So we use half of the rate in our calculations. So for this one right here, I'll just zoom back in here again. That's kind of what we're doing in this question as well when we fill out each row of the table. So we need to use 2.95%, but you see down here we're going to use half of that for each 6-month period. For half of a year is half of the yearly percent. So there are 2 interest periods per year, so that's a total of 6. Okay. So this is an interest table. All right, so let's break it down here. So this column right here is the interest period. So this is going to be year 1, this is going to be year 2, and this is going to be year 3. Everyone see that? 1, 2, and 3. And so every 6 months, the interest gets calculated. So at the very beginning, we have $5,000. That's what our initial amount is. So to calculate the simple interest earned in this period alone, you take the money that you started with here, right here, there's the 5,000, and you multiply it by half of the yearly percent, because it's half a year, and you get this amount of money. Okay? So this is the interest that you earn over that first 6 months. And so that is added in the final column, that's added to the amount that you started with that period. Okay? So here's what you get the first period. So just once again, because this is super important, because this pattern just repeats. So you take the money multiplied by the interest divided by n, or in this case it's interest times 1 over 2, or 1/2, because half a year, right? And then you add that interest to the original amount that you started with that period. Okay? So here's what's interesting. Watch what happens the second period now. Okay? The pattern starts to repeat. Except, instead of starting with 5,000, guess what? This number gets brought down to this next row. Okay? So these are all patterns that you're gonna be implementing when you fill out your table. So now you take this amount of money right here, and you do the same thing. Multiply it by the yearly percent divided by 2, or times 1/2, and then you look at this. You get a little bit more interest the second period. See, another $1 more, and you add that on to the money that you started with at the beginning of that period. So not only do you earn more interest, you add it to more money. Okay? Compound interest. It's good when you're trying to make money. Okay? So now look at this. Let's see this repeat here. So I take this amount of money, and guess what? I put it where? At the beginning of the next row. And I do it all over again. Take that money, times half of the yearly rate, get my interest, add that interest to what I started with that period, and so on. And you see how this pattern repeats. Got it? Okay. So that's a little bit different than going from your original amount all the way to the end amount with one formula. This one, you have to break it down a little bit. So we want to see how this grows over time. Okay. So to double check, you can use your compound interest formula, and you can go from the original amount, which is 5,000. You fill in all the values here, and you should get your final amount, which would represent the money that's in the last row. You see how that's the same? The last row of our table. This amount of money and this amount of money over here. Okay? Is there anything on this chart that looks strange or you don't understand so far? Okay. All right, let's go to the next page and let's do number 9. So I've already started to fill this one out here for you, so let's look at this together. And you'll need to get your calculator out, get that turned on, and get that ready to go. So what we're going to do is we're going to start off with a $3,000 investment. The yearly rate is 3.25%. It's compounded quarterly for 2 years. That means we're going to have 4 periods. N is 4. We're going to have 4 periods. So these first 4 periods, that's 1 year. These next 4 are 2 years. See that? Okay. So something else that we can do is we can, before we even start here, we can do this 0.0325, and it's going to be quarterly, so we're going to divide that by 4. And that's the number, that's the decimal number that we're going to use to find our interest each period. So what does that equal? 0.0325 divided by 4 is, so 0.008125. So this is the number right here. This is the number that we're going to use in this column. Okay. All right. So let me just get a thinner pen here. I'll use black. Okay. So let's give it a go here. I'll do the first few rows with you, and then you guys can take it on for the rest. Okay. So let's establish this pattern. So 3,000, and we're going to multiply that 3,000 times what? Okay, so the principal times the rate times the time there, or whatever. Now let's go back, just really quickly, let's just go back to this one. You see how it was, this was the yearly rate divided by 2, because there's 2 interest periods per year. So yearly rate divided by 2. So we are going to use that yearly rate divided by what? 4. So it's just this number right here that we're going to use. 0.008125. All right. So at the first, after the first, what is that? 4 times per year, that's 3 months, right? So after the first 3 months, or 1/4 of a year, we have 3,000 times our 0.08. Look at this, 2438. We'll round to the nearest cent. So that's a 7, that's a 5 there, 38. So 2438. Now, there's a little bit too much room here. 2438. Okay, that's our interest. So guess what? At the end of this period, we have 3024.38. Okay. So let's now move this amount at the end of the row down to the beginning of the next row. So 3024.38. So we're going to do 3024.38 times our decimal here again. And what does that equal? So let's see here. So there's our 3024, and I'm going to use the full decimal there. Times, actually, let's use the forget that. Let's use the actual number that's on our chart that we rounded already. So 3024.38 times, and our number is 0.008125. So 2457. Look at that, 2457. That's a little bit more than the first month's. So we'll take 2457 and we'll, 24.57 plus, and remember, we're adding to the number that's at the beginning of that row. So 3024.38. So that's 3048.95. Okay. So now for the third row and the rest of the rows, you don't have to show your work on this third column. Okay. So watch this. We're going to go 3048. Did everyone get the same numbers, by the way? Am I pumping these in right? Okay. Now let's just, I'll tell you what we're going to do. You don't have to show you this extra step. Let's just write down what the interest is here. So let's go like this now. So you've got that number. Let's just go times 0.008125. There you go, 2477. So now you can just do this, and you don't have to show as much work, okay? But I do need to know exactly what this interest is. So we'll take that, and we'll add it to 3048. And that's 3073.72. Okay. And of course, we should use our dollar signs here. Okay, please make sure you use your units properly. I'll do that myself here. Okay, so I'll get you guys to finish off that chart. Okay, do you think you have an idea of what the pattern is here now? Yeah? Okay, so you go ahead. I'll start this next row for you. You put in this right here. And then you take it from there. I'll give you a few minutes and see how you're doing. All right, so this is what your completed chart should look like. These are the values for each row. This is the amount of interest earned for each of these 8 periods. Okay. So again, all we're doing is taking, what would be this amount right here, multiplying it by the yearly percent divided by 4 because it's quarterly, and we're getting this number right here. And then we add this one and this one together to get this one. And you just keep doing that. Once you're done with this, you put it over here, multiply to get this number, add them together to get this number. So notice that, here's my pen. Oh, geez, got it. So this number right here on any row is the sum of this one and this one. Okay? So you just add the first 2 numbers up to get the third one. And then this one gets transferred down. You see that? Find out this number, add them together, and get that number. All right? So as they mentioned before, and I'll just do this on the side here, but you can use this formula, the compound interest formula, to go from this number right here all the way to this number at the end. That's what this compound interest formula is all about. But you can't find every single line by using that formula. So here's what I'm talking about. 1 plus, what is this, r over n to the power of n times t. So let's see if we can figure out from $3,000, right? 1 plus, what's r over n again? Well, that's this. Yeah, that's 0.08125. And then we have what? 4 times 2, so that's 8 periods. So you see, that's what we're doing. We're doing this 8 times. And we're adding, and we're finding the final value. So let's see if this works. Okay, so let's get to our home screen here. Okay, so we got 3,000 times 1 plus 0.008125, and take that to the power of 8, because n is 4 times 2 is 8. And look what we get, 3,200.64. And that's exactly what we get at the end. All right? So, working with that chart and being able to fill out every line, just going line by line, recognizing this very pattern right here, is what the big thing is for today. That's the first big thing. Okay? Any questions about that? You good? Okay. All right, so hopefully you got each one of those lines the same in your work. All right, now the next thing we want to do is talk about the rule of 72. So there's a rule of 72, it's called. And what it specifically does is it is a way to estimate the time it takes for an investment to double in value. So this would be helpful if, let's say you have $500 that you've saved and you want to turn it into $1,000. Okay? You want to invest it and you think, well, how long is it going to take to double that? Well, the rule of 72 is a great, quick, and easy way to estimate the amount of time that would take. So let's just read this paragraph here. If you're investing money, you may try to estimate how much interest you will earn over time. There's an easy way to estimate how long it will take you to double your investment if it's compounded annually. It is called the rule of 72. The approximate time in years is calculated by dividing 72 by the interest rate as a percent. So here it is, right here. This is the description of it right here. I'll zoom in a bit so you can read that. The years, the number of years that it would take to double your investment would be 72 divided by your annual interest rate. Okay? So this is for compounding situations, and it'll be more exact if it's compounded annually. If it's compounded monthly or daily, it'll be a little bit off, tiny bit off, but it'll be very, very close. So let's take a look at the example here and see what that says. So using the rule of 72, let's figure out how long it will take for an investment of $5,000 at a rate of 3.75% per year, compounded annually, to double in value. So the rule of 72 is super easy. 72, right here, divided by the interest rate. That's it. So what would that be? Let's see. 72 divided by the annual interest rate, 3.75. That's going to give us 19.2. So 5,000 at this interest rate will turn to 10,000 in right here, 19.2 years. Okay? And that's using the rule of 72 there. And actually it would be 19.2, so a little over 19 years. Okay? Questions? Pretty easy, right? Okay. All right. So again, let's get some more practice here. Let's do these questions together here now. So number 10 says, use the rule of 72 to estimate how long it'll take the following investments to double in value. And honestly, it really doesn't get much easier than this. This is super easy math. This is great. You take 72 and you divide it by what? The interest rate per year, and if it's compounded annually, that's gonna give us the exact. So 4. Do I do 0.04? 0.04 as a decimal or a percent? What is it for rule 72?
Interest rate
as a percent. Okay, so it's just divided by 4. Well, what's 72 divided by 4? Don't feel bad about getting on your trusty calculator. Divided by 4, 18. So what does that mean? 18 what? That means we have 18 what? Rule of 72? Years. Good. So it'll take 18 years for $6,000 to go to $12,000. See that? Like 18 years. Now, you guys haven't even been alive for 18 years. So I know this seems like a really long time. It's like, wow, why even bother? Just sit around and wait a whole other lifetime for this. Well, when you get older, you'll realize that, time actually starts to pass a little bit quicker. When you're my age, seems like 10 years ago, that seemed like just last week sometimes. So investing money for a long period of time actually isn't a real crazy idea, because one day you're going to wake up and you're going to be your parents' age. And you're going to go, how did that happen? Wow. If I would have invested some money way back when, I would have just woke up today and had double that amount of money. And I mean, maybe that doesn't excite you at all, but to have more money for doing nothing, kind of a good thing. Okay, let's see if you can do B and C. Go ahead. take a few moments to do that. All right, so B and C, there's the answers for B and C, just simply 72 divided by the interest rate. Now, let me talk about 11, okay? So number 11 says, if you wanted to double your money in 15 years, okay, so now they give you the years, and they're asking you at what rate of interest would you need to invest your money. Okay, so watch this. This is the ratio, the proportion that we have. We have 72 divided by the interest rate, right? The rate as a percent. And that's going to equal the years it takes to double. Everyone see that? So if we're in these questions here, we're given the interest rate and we're solving for years. Well, in this question, I'm given the years and I want to solve for the interest rate. So don't forget, this is just a simple proportion, and we can use the same rule of 72. Watch this. So 72 divided by, and let's just call it R as a percent, right? Equals 15. So how do I solve for R there? Walk me through the steps I can solve for R. Yes?
Could you do 15 times 72? Because it's
15 times 72?
or you could put it into our fraction.
Okay, you wouldn't want to do 15 times 72.
But you put 15 over 1 and then now cross multiply.
Okay, that's more like it. You can do 15 over 1 and cross multiply and divide. Okay? So yes, you can't just multiply the numbers you see, but you can cross multiply, which will give us 72 times 1 equals 15R. So now what do I do the second step here to get R by itself? Don't you don't want to times each side by 15. Instead, see 15 is already multiplied by R. So actually we want to divide both sides by 15. So you were very close. Okay? You were close. So now this 15 is going to divide out with that 15. See that?
Yeah.
So now really R, the percent, is 72 divided by 15. So what is that? 4.8%. Everybody get that? Okay. All right. So this is a very important formula, and you can use it to find R. You can use it to find years. Really straightforward. Okay. So that is the end of 6.2 for the lesson. So now we're into the practice your new skills. So this gives us questions from all of 6.2 now, both parts, lesson 1 and 2. So now's the time for you guys. It's open book, so look back if you need to. Use your formulas, show your work, and please go ahead and use the rest of this class time to finish the practice your skills. And I'll just show you them here on the screen. Okay. Just make this bigger so you can see this. If you get home and you've forgotten your binders for some reason, you can take a look at this and here are your questions. You can always do your work on a separate piece of paper and add it to your binder when you get back, right? Okay, a lot of questions in this practice. Okay. All right.